Alright, so video 9.2 is about points of discontinuities, or holes. In this video, it's very similar to asymptotes and stuff, but we're going to be looking at things that cancel out. So we did this a lot in class. We practiced canceling stuff out. But now we're just going to look at the examples that I have here. And anything that I cancel out, we're going to call a point of discontinuity. Since that's a mouthful, I'm going to cut that word to whole just for the video. If I say point of discontinuity 1,000 times, this will be an hour long. So a hole or a point of discontinuity is where we have factors that are in both the numerator and the denominator. So the factors that cross out or cancel out, that's going to create a hole in the graph. So if we look at my first example, start off very straightforward. We have x plus 2, x plus 3 in the numerator, x plus 3 in the denominator. If the factor is exactly the same, not kind of the same, exactly the same, in the numerator and denominator, they cancel out. So the x plus 2, x plus 3, x plus 3 canceled. So I'm left with just x plus 2. That'll come into play in a second. But if x plus 3 and x plus 3 cancel, they're canceling to form a 1. So we're just left with what I didn't cross out. So we're just left with x plus 2. The point of discontinuity is an x, y coordinate. It's a point of discontinuity. So it's an x, y coordinate. The x value is very simple. The x value is the value that we crossed out. So we crossed out x plus 3. So when we cross out x plus 3, the x value that goes with that is negative 3. So the x value is very quick and straightforward. It's the value you crossed out. The y value, I'll do this in a different color. The y value, we plug in x into the leftover equation, or the simplified equation if you want to be, I guess, more mathematically correct in your terminology. So the point of discontinuity is an xy coordinate. The x coordinate is what we crossed out. So we crossed out x plus 3. So the x value of my point is negative 3. The y value, we were left with x plus 2. We plug in negative 3, so the y value is negative 1. So we're going to have a hole or a point of discontinuity at negative 3, negative 1. Does that make sense? I'll box this because we'll need this the rest of the time. All right. So if I look at example number 2, we have x plus 1, x plus 9, x plus 1, x minus 9. So x plus 1 and x plus 1 are exactly the same, so we can get rid of those. X plus 9 and x minus 9 are similar, but they are not exactly the same. So since they are not exactly the same, they do not get canceled out. So that's what's left over. My x value is what I crossed out. So since I crossed out x plus 1, the x value of the point of discontinuity is negative 1. Because remember, we're setting all these equal to 0. So I crossed out x plus 1. So the x value that is an actual problem is negative 1. The y value, I boxed that in baby blue. The y value is we plug in x into the leftover equation. So I was left with x plus 9, x minus 9. So I'm going to plug in negative 1. then this gives me 8 over negative 10, which is negative 4 over 5. Just leave it as a fraction. Don't convert that to 0.8. If you just have to do 0.8, you can. It means the same thing. So, my point of discontinuity in the second example is going to be negative 1, negative 4 over 5. So again, the x value of the point of discontinuity is the value we crossed out. The y value is we take that x value that we crossed out, plug that into the leftover equation, and find the y that goes with it. We got to solve for that. One more. If you notice, the denominator in my example 3 is not simplified. It's not in factored form, so I don't know what's going to cancel. The only way we can start canceling stuff out is if we factor something first, and then after we factor it, then we can see what crosses out. So if we factor x squared plus 8x plus 12. And if you remember in the last video, I told you that every time we see an x squared, from here on out, every time we see an x squared, we just immediately need to be thinking, I need to factor this. I'm not going to go through the factoring. This factors to x plus 2, x plus 6. If you don't just want to take my word for it, show your work. Make sure you get the same thing. You can pause it if you need to. But since we factored that, my new equation so after I factored my new equation is x plus 2, get a little UT color in here, x plus 2, x plus 1, and then the denominator factored to x plus 2, x plus 6. And now that we factored it, here's why we factored it. Now that we factored it, do we see if something cancels out? Yes. So after we factored it, x plus 2 and x plus 2 are the same, so they get crossed out. So my point of discontinuity here, my whole, the x value is negative 2, and the y value, I'll just box that, we'll fill in the y value. The y value, we take the x value, and we plug it into what's left over. So what was left over was x plus 1. It's too small. Was x plus 1 over x plus 6. So let's plug in negative 2. And we get negative 1 over 4. So the x value was negative 2, the y value negative 1 over 4. So my point of discontinuity is negative 2, comma, negative 1 over 4. So that is the vocab word point of discontinuity.